Welcome back to Math 104. Let's use the formula to find the number of birth orders in which there are 6 boys and 4 girls. Now this is not 6 choose 4, but rather 10 choose 6, because we are looking at families with 10 children and asking about 6 of them being boys. We could just as easily ask for 10 choose 4. We are guaranteed to get the same number because of the symmetry within row 10 of Pascal's triangle. Let's actually do it the second way, so that wherever the formula has an n, we replace it with a 10, and wherever the formula has a k, we replace it with a 4. So we've got 10 factorial divided by 4 factorial times 10 minus 4 factorial. In other words, 10 factorial divided by 4 factorial times 6 factorial. We can write this out as 10 times 9 times 8 times 7 times the rest of the numerator is going to be 6 factorial. So times 6 factorial. All divided by 4 factorial, that's 4 times 3 times 2 times 1, times this 6 factorial. And here we have our fantastic cancellation. This cancellation is much less important when you're doing the computations on a machine than when you're doing them by hand, but it's still important to understand that underneath it all, this cancellation is taking place. At the end of the day, we're computing a product of 4 numbers in the numerator divided by 4 numbers in the denominator. This turns out to equal 210. Now you could expand Pascal's triangle down to row 10, but the formula gives you a direct way to compute the number of birth orders. In the last video, we asked about the probability of getting an exactly equal number of heads and tails on 30 flips of a fair coin. This equals 30 choose 15, the number of outcomes in the event, divided by 2 to the 30, the total number of different possible outcomes in the experiment as a whole. To compute this, we really want to apply the formula rather than expanding Pascal's triangle to compute this numerator. And when you write it out, it does look a bit intimidating, even if there really is a bunch of cancellation here. In practice, you're going to do this on a calculator or a computer, so let's actually look at some shortcuts. On a calculator, there is usually a factorial button. You might have to search for it a bit. Sometimes there's a button for math-related functions, sometimes there's a button for probability-related functions, and somewhere inside the menu there's an option for factorial. What you really have to be careful about is typing in 30 factorial divided by parenthesis 15 factorial times 15 factorial. If you omit the parentheses, the calculator will think that you want to calculate 30 factorial divided by 15 factorial first, and then whatever that is, multiply by 15 factorial. That's if you omit the parentheses. If you wanted to compute this, you must include the parentheses. Your calculator might also have a built-in function for n choose k, and this is often denoted NCR on the calculator. This might not be a button, but rather an option somewhere inside a menu. Please don't hesitate asking for help on how to find this inside your calculator. There are also a number of online n choose k calculators, where you input n and k and it computes n choose k for you. Here's one of them. We just input 30 for n and 15 for r. This is the number of outcomes in our event. That's still not the probability. We still need to divide this by 2 to the 30th. Just to illustrate one way of doing this online, there are lots of online calculators, but you can actually have Google do the computation for you. So this number we just found as the value of 30 choose 15 divided by 2 raised to the 30th power. So this caret means exponents. And let's see what Google tells us. Behold, this is the probability that we're looking for. This is the answer to our question. This is the probability that on 30 flips of a fair coin, the number of heads equals the number of tails. Just to give one other way of doing this, if you search for Google Calculator, it will take you to this same calculator we were looking at, and you can directly type in 30, notice there's a factorial button, divided by parenthesis, very important, 15 factorial times 15 factorial. That equals the number of outcomes in the event, and then that divided by 2, and here we have the exponentiation button, 2 raised to the 30th power, and that equals our answer. So there are lots of ways of doing this computation if your calculator doesn't have a factorial button or it's not easy to find. Just to give you one other technological option, spreadsheets are very good at doing this kind of computation. Here we've got Microsoft Excel. There are others, but Excel does this very nicely. If I type in equals combin, that's the name of the function, short for combinations. That's some terminology that's actually quite misleading that we deliberately don't use in this course. But that's the name of the function for n choose k. So combin, parenthesis 30, 15, lo and behold, that gives us the number of outcomes in the event. We now take that expression and divide by 2 raised to the 30th power, again using caret for exponentiation. Sure enough, that gives us the same answer as Google did. Now that you have all these nice ways of doing the computation more easily, before going on to the next video, recall the model of a stock price which either increases by $1 or decreases by $1 every day with equal likelihood. Now find the probability that after 30 days, the net change in the price of this stock is exactly $10. So think, in 30 days, how many ups and how many downs do there have to be for the net change to come out to exactly $10? That could be a $10 loss or a $10 gain.